Welcome back to my channel. We want to talk about a rearrangement reaction, and that is Pinacol and pinacolone rearrangement reaction. This is called pinacolone rearrangement reaction. That is because of the diol and the dimethyl group reacting in the presence of H2SO4, that is the dilute H2SO4, to form a dimethyl ketone group. That we get the pinacolone rearrangement. So let us see how we got to this place, and that is to show the mechanism for this reaction. So that is what we are going to do now. I want to show you the mechanism for pinacolone rearrangement reaction. So to get this exact pinacolone here, the first thing you have to do is to protonate this hydrogen. After protonating the hydrogen, the next thing you do is to dehydrate it or dehydrolyze it. That is to remove water from it. And after removing water from it, the next thing you are going to do is to bring a methyl group down to this other place here. So after bringing the methyl group there, this is called 1,2-methyl shift. And after the 1,2-methyl shift, the next thing you do is to deprotonate it. That is, we are going to remove the second hydrogen from the reaction. So that means there is totally no hydrogen left in the reaction. So let us just quickly show that by starting with it immediately. So this is the reaction here. So let me just show you this. Oxygen has 3 lone pairs of electrons, and it's using one to bond with our hydrogen here. So remember the first step I stated. The first step is that it will be protonated. Now this bond here will attack the hydrogen, therefore protonating it, and this is what the reaction will form. Okay, this is what the reaction will form. These are OH, and this is the oxygen here. One of the bond has bonded with hydrogen, and we are left with just one lone pair of electron, and the other here is bonded with the other hydrogen. So this is the first step. Protonation is the first step. Now the second step is what we want to see. Like I said before, it will be dehydrolysis or dehydration. Is the same thing. Dehydrolysis, dehydration is the same thing. It all has to do with removal of water. So that is what I'm going to show now. Yeah. Okay, we have our other hydroxy group here. But now, since we are removing water from this reaction, this water here, since we are removing the water from the reaction, this place now will be positively charged because the whole of this place is left. So we have a positive charge here. So that is the second step. Now, over to the third step. For the third step now, it will be a 1,2-methyl shift. That is a methyl group from this place, that is the methyl pointing at you, will shift from carbon 1 to carbon 2. So that is what I'm going to show you now. Okay, these are OH, and this is the methyl group. Now this is the methyl group that came in. So this is the methyl group that came in here. So we have a reaction here. So after this 1,2-methyl shift, what I said is the next step is to deprotonate the reaction, because gradually now we are getting our pinacolone. So we are going to deprotonate this reaction. So where can we find a proton here to deprotonate? The only proton left here is this hydrogen. So we are going to remove this hydrogen. And again, this oxygen still has 3 lone pairs of electron. So here is one and here is one. It's using this one to bond with this oxygen. So the protonating heat, that is removal of H, the protonating is it now. This hydrogen is going to attack this place here. It's going to attack the oxygen. Why this other lone pair here, we attack this bond. Now let me show you what we are going to get from that. This is what we are going to get from that reaction. This is attacking here. We have a double bond and we are left with O. And we have a methyl group here. Another one here too. And here we have the reaction. So it's simple, very, very simple. This is called the pinacolone. So this is the mechanism for pinacol, pinacolone, rearrangement, reaction. So if you find this video interesting, please do well to subscribe to my channel so that we'll do other mechanisms for other types of reaction. So thank you very much for watching the video to the end.